As you might have noticed, when you're doing a tree diagram, it can get very big very quickly. Sometimes it's impractical because you have so many choices. So if you have so many choices, what we're going to do is we're going to do something called the fundamental counting principle. And here's all it is. I'm going to take all my choices for my first event times all my choices for the second event times all my choices for the third event, and so on. So if I take a look at example 7 here. Here we have Soraya, and she's going to make a schedule. She has 6 different courses of art history. So if I was making a tree diagram, I'd have to start with 6 different categories. And then off of that, I'd have to draw 5 different categories. So already notice I've got 30 different choices. So to find the total number of different schedules Soraya could make, we just take each outcome. There are 6 for art history. There are 5 courses for French, 9 courses for math, 4 sections of art, and 6 sections of English. Rather than making a tree diagram, we're going to multiply them together. And if I take 6 times 5 times 9 times 4 times 6, we get 6,480 different courses, schedules she could have. So she's got a lot of choice in there of how her schedules work out. When we look at 2 things, we're going to look at intersections and unions. Intersection means both occur. Okay? When you have the intersection, notice you get this little horseshoe. It means both parts. And when I have A and B from my Venn diagram, this section is going to be A and B. It's going to be in circle A and in circle B. So if we take a look at example 8, I want to look, a fair die is roll. So I'm going to let A be the event of rolling an odd number. So if I'm going to list out my sample space for A. So I'm going to go 1, 3, and 5. Then for B, it's rolling a number greater than 3. So I could get 4, 5, and 6. Well, A and B is going to be where I have the parts that are in both sets. Notice 5 is in both sets. So I'll have a 5. That's your intersection, A and B.